Hello and welcome to my YouTube channel. I am Instructor Allison, and if you are new to this channel, consider hitting the subscribe button, like this video, and turn on the notification bell so that when I upload new video you get notified. And for the returning subscriber, thank you very much for always coming through to watch my videos. I really appreciate it. So here in this video we're going to solve by mathematical induction. That's 5 to the power of n plus 2 into 11 to the power of n is divisible by 3. So this is one question that students are always having challenge on, and then in this video I consider working step by step to show you how you can solve problems like this. It might not be always divisible by any number, it could be multiple of any number, and as the case may be. But let's get started with this. I hope that you will found this video helpful. So the first thing, according to the principles of mathematical induction, we have about 3 steps basically that we always go about. And the first is that we show that n equal to 1 is true for all positive integers of n. We also assume by step 2 that n equal to k is true. And then step 3, by the assumption we would have made on step 2, we show that n equal to k plus 1 is true for any positive integers. So that's the step we're going to also follow on this. It's not quite different. So on step 1, we're going to show that n equal to 1 is true. So let's do that right away. So what do we need to do? Look at the problem. 5 to the power of n. It means anywhere I see n, I'll plot in 1 from that problem, plus 2 into 11 to the power of 1. So if you evaluate this problem, 5 to the power of 1 is 5 plus 11 to the power of 1 is still 11, and 2 multiplied by 11, that will give you 22. And if you add up 5 to 22, that will give you 27. And of course, you can notice that if you put in 3 here, 3 goes into 27, it will go only 9 times. So this is like, I want 3 into 9. Alright, so you can see that 3 is divisible by 27. Because 3 times 9 gives 27. So because 3 is divisible by 27, you can conclude that n equal to 1 is true. Alright, that's for the first step. So what happened in the second step? In step 2, we're going to make an assumption. We assume that n equal to k is true. So what essentially we need to do is to plot in n, k for n. So we have 5 to the power of k plus 2 into 11 to the power of k. Alright, so but then we have to equate this to, remember that we say we want to check if this is divisible by 3. So we just add 3 and any variable you can think of. In my case, I want to use e. Alright, you can use any variable of your choice when you're doing this analysis. So that's for step 2. So from here you can just conclude that n equal to k is true because we are making assumption. So we just leave it here and just make this equation 1 if you want, because we'll still make reference to it. Alright, step 3 is about proof. We're going to show that n equal to k plus 1 is true for all positive integers. So what it means that from that original question, anywhere you see n, you plot k plus 1. So we have 5 to the power of k plus 1. What's the next number there? Plus 2 into 11 to the power of k plus 1. So this is what we have. And what are we supposed to do from this point? It's not something difficult. So I would need to see into bringing in equation 2 or equation 1 rather into this system. But before then, we need to simplify this problem. And how can we simplify it? I want to show you this model in indices. You remember that when you have a to the power of m times a to the power of n, when the bases are the same, you take one of the base and you add up the power. That means this can be transformed to this, and this can be transformed to this. So if we want to make this one, which is like this, to come to this point, it means we just have 5 to the power of k times 5 to the power of 1. I hope that is clear, because the base are the same. You take 1, you add the power, you have this. Similarly, you do that into this 1 into the bracket, in the bracket, 11 to the power of k times 11 to the power of 1. Alright, so you can see how simple that is. So the next thing I want to do is that, look at equation 1. We have 5 to the power of k. So, but I want to make equation 1, 5 to the power of k in equation 1, the subject of a formula. Just say, make a statement from equation 1, make 5 to the power of k the subject of the formula. Alright, maybe you can just make this one equation 2, so that we can make reference to it too. So how can we make 5 to the power of k the subject of formula? You just say 5 to the power of k equals 3e minus 2 into 11 to the power of k. That's all. That's all you've done. You can make equation 3. So from equation 1, you've made k, 5 to the power of k, the subject of formula. So I want to plot in this 5 to the power of k into anywhere I say 5 to the power of k in equation 2. That means we are substituting equation 3 into equation 2. So take note, this is 5 to the power of k. This is 5 to the power of k. This is the value for 5 to the power of k. That means in place of this 5 to the power of k, I will replace it with this one. So watch, I will have 3e. I'm substituting this one for this. 3e minus 2 into 11k. All this shall be multiplying by this 5 to the power of 1. And you know that 5 to the power of 1 is still 5. Plus, we have the rest of the expression, which is this 2 into 11 to the power of k times 11. Of course, you know that 11 to the power of 1 is 11. Alright, I hope this is clear. So we want to use this 5 to clear the bracket. Of course, you know that 5 times 3 is 15, then e minus 5 times 2 will be 10 into 11 to the power of k. Alright, plus, in this case, we have 2 times 11 will be 22. Alright, let's still leave this 11 to the power of k in the bracket. So you can observe that 11 to the power of k, they are common in this case. So because they are common, so we have 15e. I will factor out this one that is common. So if we have minus 11k, let's check. And I open this bracket. What will be remaining here is just positive 10. Is that true? Because this one times this will still give you back this. And then if I have minus here, I will have here to be 22. If you make this place plus, the equation will not be correct. You have to make it minus, so that if this minus also multiplies by this minus, it will give us this plus that is here, 10, 22, and 11k. So that's what you should do. So you have 15e minus 11 to the power of k. And then if you subtract this, 10 minus 22, what will be the answer? That will be minus 12. Alright. So if you decide to use this minus 12 to clear the bracket, then you'll be having 15e plus 12 into 11 to the power of k. So that's where the equation will end. Now let's check if this particular expression is divisible by 3. Can 3 go into 12? Yes, of course. 3 can go into 12. How many times? 4 times. 3 can also go into 15. How many times? 5 times. That means this equation, the last part of its equation, is divisible by 3. So because it is divisible by 3, we say n equal to k plus 1 is true. So here is the end of this problem. I hope you found this video helpful. Please make sure you hit the subscribe button, turn on the notification bell, so that when I upload new video, you get notification. And also make sure you like this video, share it to your colleague because they might need this video for the exam preparation. Thank you very much for watching.